In this lesson of 9.4, we're going to be looking at the tangent ratio. Tangent ratio, as we start to look at it, obviously it's a ratio, so we're going to think about like a ratio of our fractions, whenever we have something compared to something else, one over the other. And so tangent ratio, and just in general what we call trig and trigonometric ratios, okay, like I said, short word for this would be trig. You'll hear this a lot as we do trig functions. Is when we compare two different sides of a right triangle. So we already know whenever we look at triangles that they have a similarity, and we know that they're going to be similar. We know they're going to be proportional whenever we set up these ratios. And so out of that we get this trig ratios, which one of them that we're looking at today is just tangent. And tangent is just going to involve, it's going to involve the legs of our triangle, of our right triangle. Not the hypotenuse, but just the legs. And tangent, as we start to look at it, we look at, obviously we're talking about two legs. So in order to distinguish between the two, we say the opposite leg and then the adjacent leg. Okay, obviously opposite means it's going to be across from it. It's like on the opposite side, so it's across. And then adjacent, remember, is right next to it. Okay, adjacent's when it's right close by, it's the very next thing, so it's next to it. Okay, so when we think about tangent, tangent of an angle, okay, tangent of A, this, whenever we say tangent of A or tangent of whatever, this A is referring to the angle. Tangent of an angle is equal to the length of the opposite leg over the length of the adjacent leg. So if we're looking at angle A, here, if I mark it, okay, I'm going to look at my opposite leg over my adjacent leg. Okay, that's how we do opposite over adjacent. So if we go ahead and look at doing the other angle, say we look at doing angle B, so we want to take the tan of angle B, we would say tan, which stands for tangent, would equal the opposite leg of angle B, so opposite across from it, it doesn't touch opposite, would be our AC, over the adjacent, whatever's right next to it would be BC. Okay, so tangent of A was the BC over AC. Tangent of B is the exact opposite, okay, because we just flipped those two sides. We're still using the legs, but we're on the other side. We're doing a different angle, so they just flip. So let's start to look at this a little bit more. Okay, in this example 1, it tells us to find the tangent of S and the tangent of R. Okay, whenever you're working this, so tan is just the abbreviation, TAN. Okay, but whenever we're stating it, one thing to remember, this is called the tangent of angle S. Okay, don't tell me I'm finding the tan of S. Okay, and you're finding the tangent of angle S. So let's start with that one first. If I do tangent of S, okay, it's going to equal the opposite leg. So opposite does not touch it. It goes across from it. So that would be our TR over our adjacent, the side that's right next to it. Not the hypotenuse. We said leg. So the leg right next to it is ST. Okay, we're not doing hypotenuse at all right now. So if I plug those in, TR is 80, ST is 18. And so I could reduce that down to 40 over 9. But if I want the approximate answer to actually find the tangent of angle S, we can put in our calculator. And so you can do your 40 over 9 or your 80 over 18. And you'll get approximately 4 point, and it says up here, it says to round it to 4 places. Okay, so 4 decimal places. I'm going to kind of run out of room here. But I would do 4 point, and it just repeats 4s over and over again. So I'm going to rewrite it down below. It would be approximately 4.4444. Okay, 4 places. So we have our decimal answer here, and we have our we have our fraction answer here, and we have our decimal rounded to 4 places. Then we also need to find the tangent of angle R. So I'm going to do angle R is here. Okay, so tangent of R would equal, again, we're going to do our opposite over adjacent. So I'm going to go across from it. My opposite is ST over my adjacent is TR. If you notice, it's just flipped from tangent of S. So I plug these in, I get 18 over 80. This reduces down to 9 over 40. And then to get our decimal, you just put it in your calculator to get the approximate value. So 9 divided by 40 gives us approximately 0.225. Okay, and there's nothing after that, so I can't do 4 decimal places. I didn't have to round it. And so this would be my answer. So far, we're finding these tangent ratios, right? But it kind of seems like, what's the point of them? Okay, we're finding some ratio. How does it help us? It becomes more apparent to us and how it's helpful whenever we actually are missing a side. When we have one of our angles and we're trying to solve for a side instead, it becomes more apparent why this ratio is so important. So in this example, example 2, it wants us to find the value of x. Okay, so we're going to do this angle that we have here, this 32-degree angle. Okay, and we're going to find the tangent of it. So if I do the tangent of my angle, 32, it will still equal my opposite over adjacent. So my opposite is my 11 over my adjacent of x. Okay, so whenever we're working a problem like this, work this tangent of 32 as though it's one variable. Okay, just like as though it was a y or an x or whatever. We're going to just carry it together like it's one variable. So if I want to try to solve this, I need to try to get my x in the numerator, so I'm going to actually multiply both sides by x, so that way I cancel out here. And so I get x tan of 32 is equal to 11. To get x by itself, I need to divide, because right now these are being multiplied. So I'm going to divide by tangent of 32 to both sides. And so it cancels out here. And so I get x is equal to 11 over the tan of 32. Okay. To solve this, you can put this into your calculator. So whenever you type it in, you would do 11 divided by, you have a function that will say tangent. Okay, or it says tan, it says TAN. You can use that function, it's on your calculator, it's on if you're using a mobile device like your phone, it'll have those on there as well, and we can show you in class. And so you can actually take the tan of 32 and give me the approximate answer. So when I do that, I'm going to type in, like I said, I'm going to do 11 divided by the tan of 32. And so when you do that, you're going to get a decimal. It says to round to the nearest tenths, okay? Nearest tenths place is 1 decimal place. Okay, so when I do that, I will get 17.6. So x is approximately 17.6 units long. In example 3, we're going to use a special right triangle. So it says use a special right triangle to find the tangent of a 60-degree angle. Okay, remember we have 2 different types of special right triangles. We have our 45, 45, 90, and we have our 30, 60, 90. Okay, since this angle is 60 degrees, that means we need to use our 30, 60. And so when we draw that out, we have a right angle, we have a 30-degree and a 60-degree angle. Okay, remember our relationships for these is we have x square root of 3 here, we have x, and we have 2x. Okay, I just have to use one special right triangle. So I'm just going to plug in a value for x. I'm going to just say x is equal to 1. Okay, and that will give me one triangle. So if I go back in, and instead of doing my x, I'm going to put in a 1. Instead of 2x, I just get 2, and instead of the square root of x square root of 3, I just get square root of 3 if I plug in a 1. So using the special right triangle, it asks us to find the tangent of the 60-degree angle. So the 60-degree angle, we're going to do our opposite over our adjacent. Okay, this is our opposite. This would be our adjacent to 60. And so one thing is you start to pick your reference angle, whichever angle you're using, you can start to identify the parts of your triangle. So I wrote here just OPP for opposite, and I wrote ADJ for adjacent, and this part would be my hypotenuse, right? That part wouldn't change on my triangle. Okay, so I need my opposite over adjacent, so when I take the tan of 60. My opposite is my square root of 3. My adjacent is my 1. So, in this problem, the tangent of 60, when I reduce the right side, and if I divide by 1, it doesn't change anything, then I just get the square root of 3. Okay, and so that's my answer. In the tangent of 60, I always get the square root of 3. Okay, and then before we look at our last problem, example 4, if you'll notice at the top here, we have angle of elevation. Angle of elevation is when you are looking up above the horizon. Okay, so if I'm looking straight ahead first, just looking horizontal with the ground, if I look up some, that becomes my angle of elevation. You can think about an elevator, it goes up. Typically you use an elevator to go up more so, right? Because you don't want to take the stairs. Okay, so that's when I go up from the ground. When I start it horizontal with the ground, I go up, angle of elevation. So in this problem, it says we're going to measure the height of a spruce tree. It says you stand 45 degrees from the base, and you measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Okay, so find the height of the tree to the nearest foot. So when we look at this, if this is our angle here on the bottom, this is our reference angle that we're talking about. If I'm using this angle, then across from it, this is my opposite. Right next to it is my adjacent. Across from the 90-degree angle is always my hypotenuse. Okay, so when I use this, I'm going to use tangent, okay, because I have my adjacent angle or my adjacent side already, and I'm looking for my opposite side. Opposite over adjacent, I can always use tangent. So when I go to use this, I'm going to do my tangent of 59 would equal my opposite over adjacent. So in this case, this is my h over my 45. Okay, so right now the height is being divided by 45, so to undo division, I'm going to multiply both sides by 45. So it cancels out on that side, so I just get the height is equal to the 45 tangent of 59. So when you type this in, this is like one big thing. It's being multiplied. When I have that 45 outside the tangent, it's being multiplied with the tangent of 59. Okay, tangent works like a function, and so we're taking the tangent of 59 degrees. And so when you type this in, you're going to type in your calculator. You can type in 45, and then find your tan button on there, tangent button. And then you would type your 59. It'll bring it up to where it'll look like tan, and it'll have like parentheses typically. And so you'll type your 59 inside that parentheses. So it tells the calculator you're taking the tangent of 59 degrees. And so when you do that, you should get a decimal, and it asks us to round it to the nearest foot. So whenever I did this in my calculator, I got 74.89, but nearest foot means I'm not going to do any decimals. So my 74.8 makes me round it up, so it would be 75 feet would be my height. Okay, and that's it for this. For doing tangent, we'll be looking at more trig functions as we start to go along. Make sure you're asking questions in class. If you're not sure how to put this in your calculator, be sure you're asking. If you're silent, it's hard for us to help you, but if you ask questions, then we can start to work through some of these things.